So yeah, in some ways, kind of just doing it, you'll kind of learn it as you go along, because I've kind of broken it down. And then the one to be, right, that's where you start tying it together. But I also have kind of examples and things like that, to show you this is what it looks like to set it up. This is what it looks like to justify it. All right. I am thinking, going through my mind the questions of this past week. I'm thinking I know where maybe people are going to get hung up, and I could maybe go slower about it. But before I do that, Shreyan, do you have any questions?
I do. But
Yes.
so with the signal multiplication.
Okay. And you know what? That's all right. Great minds think alike, because that's what I was going to do.
Convolutions, I believe that's the right phrase.
Well, we haven't quite gotten to it yet, but there's no harm in it and getting a little bit ahead of the game.
Okay, because I was doing it in my lab yesterday and I had no clue what I was doing.
Yeah. Okay, right. Which, maybe I should do that.
There's just one specific one I would like an explanation for.
Oh, so you have a very specific question.
Yeah.
Is it up on your screen?
I can write it on my screen.
Oh, the annotating.
Oh, should I do the annotate or write it on my screen?
No, I'm going to stop sharing. You share your screen. That way
Okay.
it'll be faster if you tell me.
Okay. U of t.
Yeah.
Convoluted by delta t minus e to the negative t.
Yeah.
Of u of t.
Yeah.
I know the answer to this, but I don't know how we got to the answer.
Yep. Okay. All right, I'm gonna take the screen back.
Stop sharing.
Okay. And maybe, yeah, by doing this will actually be the review too. Okay. So, and I'm assuming you mean mathematically how to do it.
Yeah.
Okay. So, oops. So, yeah. And I'm just gonna kind of, as we go along, review things. So we have UT, right, on the time axis. Does this, right? And it goes to 1 exactly at 0, right? I can make it bigger, I can delay that step, and I can advance that step. Then we have delta t, right? Which, and I'm not saying you have this question, but I know it just comes up. Like, if it's just delta t, I draw it 1 unit high, right? But really it's infinity high and infinitely thin, right? And I can scale it, I can delay it back and forth, right? Then we have, and I'm just putting E of t, okay? E to the minus t, sorry. All right. So, you know, -1, -2, and see how it's always on. Okay. So, so what we're going to do, and I'm going to just, we have U of t, and that's the convolution symbol, right? Delta t, minus, it was minus, e to the minus t u t. Now, sometimes when I get going quickly, I'm very used to writing mu for micro, but I really am trying to write step. So that little kind of, you know, when I'm going slowly, yeah, there's my u. But when I start speeding up, all right. So now, since I haven't done the convolution yet, I'm just going to say, let's keep it high level. Okay. Convolution, right, is I take an input, and convolution turns it into an output of the system. Okay. And so some, we already kind of know that if, oops, or you might have seen. So if this system, and is e to the minus t ut, that's, we're describing the system, all right? And if the input is a step, okay, and what is that? The circuit of that is this, right? That's in and that's out, right? So I put in a step, and what actually comes out is this, 1 minus e to minus t ut, all right? So that symbol, right, is this, that's the big picture. That's what's going on, all right? And again, I'm going back a little bit more than just your question, all right? So the time domain convolution equation, right? So I'm just going to give it two names, g of t convolved with h of t. And yeah, this is just math. That doesn't really have to be the input signal, and that really doesn't have to be the system equation. And you can put them in any order, it doesn't matter. It's just convenient. So in this case, we're calling u of t, g of t, and then this is the system equation of that. And really where it came from, this is the circuit. This is in, and this is out. Okay. And it's a high pass filter. It detects edges. So if I put in a step, which is an edge, right, what'll come out is the fact that there was an edge, you know, some other information. All right. So again, just so we don't lose sight of the big picture, right? That's why I'm kind of dragging out the answer. So now what is the mathematical, and just to make it easier on myself, I'm going to say f of t, right? So f of t now we have to do it, right? And I'm just going to start with the 0 here, and it'll just make our lives easier. So the function of t has to have t, you know, be dependent on t, and that's why it's in the upper limit. All right. Now because t is in the upper limit, we have to use an integration w variable, and that's tau, right? So the first part, u of t, is somewhat easy. You just bring that over and call it u of tau. And I know I'm going to run out of room here. Okay. And now that we're integrating, we can put multiply, okay? And we have delta t minus tau, okay? E to the minus t minus tau, u t minus tau, close it, d tau. Now, there's a lot of tricks with time domain convolution in that you might think that these integrals are going to be harder because there's more going on. And you'd be right. So in fact, this kind of, and I'll write it out generically here, g tau times h t minus tau. Sorry, d tau. All right. Now, actually, it can be g t minus tau and h of tau. You can switch it. And in this case, you might want to. Now, this is, I think, we're about to get into the hard conceptual part, because you could follow this along mechanically, right? Is what the hell is going on? We just put in a minus tau, so now all the functions are time reversed on the
Yeah, I think you're having issues again.
No, I hadn't clicked on the thing. I was on white. So now if I have, what's u of tau on the tau axis? Oh, you mean you can't see what I'm drawing?
Oh, no, it works now. You were just on the
yeah,
white
no,
one.
that was. Okay, I'm sorry. The Chinese characters I'm not familiar with, although the first one I think is Da, because David is Da Wei, I think, in Chinese, and so I know the first character, but I'll review it later. But this was a big question, and I'm answering the first question first. But I will get to you, okay? So so this is u of tau on the tau axis, right? But now we have this e, but now that an e to the minus t, right? I'm just going to go down here, was like this. But now it's time reversed, and so it's going like that. But then, oh Lord, then you have, so I have minus tau. So on the tau axis, it's actually doing this. But then I have this minus t, which is actually acting like an echo. All right. So I'm just going to take a second here. I'm integrating up to tau, right? But I'm reversing in time the the variable we're integrating over. And it's really just like you're summing up echoes. All right. Now I have notes on, I start off doing this discreetly and then kind of showing where it comes from. Right. But try not to get too wrapped around the axle about that. All right. And I also have videos that kind of show you what's method, doing it physically. But I just want to kind of stick to this question. All right. So I'm going to switch it. So now I'm going to have U T minus tau. Right. So now that's G T minus tau. All right. And then I'm going to multiply that by now just delta tau minus E to the minus tau U tau. Because that'll just make it easier. Okay. Now, of course, oops. And that's my tau. All right.
Why is delta in T, but E is to the power of tau and use?
Because it's really hard not to accidentally draw a T.
Okay, got it.
Okay. I mean, that's kind of the truth of it. But now what we want to do is, so the first step though, is to break this up. All right. So I'm gonna take this and U to the T, U T minus tau, delta tau, d tau, and then because a lot of times with the delta function, it's almost like you're doing it by inspection. Okay. Oh. I was right. So this U tau comes from there, and then this UT, comes from there. And so actually I've got this, there's two step functions multiplied by each other. All right. But that's actually not that hard. So now here's the thing. This is zero. This zero means this function is zero before time equals zero. All right. And now we're after it. And so the thing is you just replace this with 1. All right. Because it will be 1 because we're integrating between 0 and t. All right. And we're just kind of summing up reverse echoes, but it effectively just has to be 1. All right. So, and sometimes what folks will do to kind of notice that is say, well, I'm going to put it in minus infinity there. And I'm going to keep a minus infinity here. Right. And a minus infinity here. But now that I've said it's 1, because I'm no longer saying minus infinity. I'm saying I'm going from here. Now I'm at 1. All right. So that's a way to keep track of it. But you have to manually know that you're doing it. All right. So anyway, so if I'm integrating, right, and I integrate something infinitely high and infinitely thin that has an area of 1, well, then the area goes 1 and never comes back down because I'm integrating with t. So then and I think really I can try to pretend that there's this, you're doing these things that make that happen, but really you just know that that's true. Is that if I'm going to integrate a delta function over time, really I'm going to get ut. That's just the way it is. Now over here, zero t. Now I'm going to say 0. And again, now even though it's t minus tau, you can't, for step functions, you just replace it with 1. And here's the thing, and this is u tau. Oh, and I forgot the u tau. That just becomes 1. And that becomes tau. Okay. Which becomes minus sorry, I'm running out of room a little bit. Anyway, this becomes e to the tau. Okay, 0 to t, right? But let's see, I take the derivative of this and I get minus this, and then minus times a minus, right, will give me a positive. So I have to no, I'm making that too hard. Anyway, it was minus. All right, because when I take the derivative of this, it's negative, and it was originally negative. Okay. So this, right, we get e to the minus t minus e to the 0, which is e to the minus t minus 1. Now, if you recall, the original equation started at 0. So the area has to be 0 before time equals 0. So the only way to do that is because, right, e to the minus t will do this, right? E to the minus 1, I mean, minus 1 is minus 1 for all time. But I need this to be 0. I mean, I need to force this to 0, right? And I need to force this to 0 before time equals 0. The only thing, and again, you have to know to do this. The book makes it seem like there's rules about it, but the rule is you got to remember to do it. So now, what forces that to 0? UT, right? So 0 times this is 0, 0 times this is 0, 0 times this is 0, 0 times that is 0. 1 times this is the thing, 1 times this is the thing, and then you just, multiply it. Here, minus 1 times 0 is 0. So it's 0, 0, 0, 0, and then you get your minus 1, right?
In the previous layer, you had g of x equals something or g of t equals something.
Oh, I got to go back and get the original part. So the first part was UT, right? So I was just working on this last part. All right. Now I got to bring up the UT. All right. So f of t from the previous part is u of t, right? Then plus e to the minus t ut. And I'm going to expand this out, minus ut. And so look, that ut and that ut cancel out. So in the end, I get e to the minus t ut. And where does this come from, really, is if I have a step function, oops, I have this, okay? And this is VC, and this is VR, okay? In the book, done in a differential equations format, right? Let's just call that out. V out equals VC equals 1 minus e to the minus t ut. And what I'm saying is you can look in the book for how they do it, but this would have been an EE98 thing, all right? Which I had an intuitive way to solve, right? Now, this circuit, oops, sorry. VC, VR. Well, here's the thing, right? In a mesh analysis, this current, if R and C are the same as C and R, and it's the same input, it's the same current, right? And so really, in this case, VR equals V out VR equals V out, which was VC to begin with, right? So after the step, this is just 1. So I get 1 minus this V out, and you'll get the same answer. And then, or you can say, these two VCs, they're the same, right? And so I can, if Vn equals VC plus VR, I can solve for it here. And so if I find out VC here, it'll be the same here, which then gives me VR and VR, which is the high pass. So VR will equal e to the minus t ut. Okay. Which is, quite a bit. Any questions?
Hi, instructor.
Yeah.
Yeah, I have a question about the homework assignment. So you
Okay.
say you are extend the deadline for
Yeah.
2A and 2C, right?
Yeah.
So when is the due date for the two?
Well, just look it up on Canvas. It's the until date. I changed the grace period.
Because I see the Canvas is like also still like this Sunday.
No, just the due date didn't change, but the day I'll accept it without penalty has changed. So
Okay,
you just got to click on the assignment. You know what I'm saying? Yeah. All right. No penalty.
Okay.
All right. So there's just a few. So there's like a skill that you might not get that I just want to. I just want to integrate this. So it's a function in time, right? So how do I
Not
deal
seeing
with
the screen.
Oh, did I stop? No. Can you see the screen?
Yes, we can.
Okay. So here's the thing. All right, I want to find a function in time, f of t. Right? So I'm integrating f of t. So, here I am, u of tau minus 1, right? So how do I deal with that? Right? And in a way, we're getting towards t minus tau, right? Well, the thing is let's just plot it out. If that's 0, that's 1. This is 0 up until 1, right? So replace the lower limit with 1, right? That's a delay of 1. That means it turns on at 1. And when it turns on, it's 1. So now all I have to do is 1 d tau. All right. And now, so let's just think, I'm integrating a delta area, delta, taking a delta, taking a delta, taking a delta, delta, right? And since the width, right, there's a finite width, but the height is really 0, right? Because it's 0. So I'm getting 0 up to 1, and then I start getting this, right? And it's now it's this height or this height times this width, and I'm adding it, and it's linear, right? So you might think, oh, that's just t, right? But it's not just t, it was t delayed by 1. And that should come out here, right? If I do this, right, I get t minus 1. But t minus 1 is this. But remember, the area was 0 before 1, and it was going 0, 0, 0, and now it's going, and I'll just pick a different color. So it's 0, 0, 0, 0, and now I'm getting a ramp, okay? And how do I enforce that? I have to put a ut minus 1. And then there becomes some tricks that aren't really needed for this homework, but I'm just going to give you, and what it is the book shows you the trick late, and there's no reason for it. But there's some very common convolutions, all right? Let's just say delta t convoluted with delta t, right? Well, remember there's an integration in here, right? Delta tau times delta t minus tau dt. Okay. Oh, sorry, that was my delta symbol. Sorry. Well, remembering, right? Delta functions always give back the original function, really. Okay. And so if I'm, if I just integrated a delta function, I'd get a step. Well, now I'm just kind of multiplying delta function by a delta function. So I should get u of t, right? And then or no, that should be delta t, because you get back the original function. But if I convolve this, I get back the original function. If I convolve delta with RT, I get RT, right? With exponential, I get the same thing. And so if I convolve delta t with ut minus 1, well, I don't really have to go through all that rigmarole. I just know that I'm going to get ut minus 1. Now, this is probably a little more today, but now you might be thinking, I got to set up this whole complex convolution integral, and I'll just write it out. Ut minus 1 would be u tau minus 1 times u T minus tau minus 2 d tau, and then you got to deal with this, and where does the limit go? And it's honestly, it's just too hard. Okay. Here's the thing. A step function convolve with a step function. And now I'm just going to switch. And this is a little bit for later, but since we're on the topic, U of t convolve with U of t gives a ramp of t. Now, the delays, actually, you just sum them up. So if I have ut plus b convolve with ut plus a, and they can be positive or negative. It's just a ramp plus a plus b. So you actually only have to know things like, well, the delta times a ut, delta times ramp, those are just kind of done by inspection. But you have ut convolve with ut, ut convolve with ramp, ramp convolve with ramp, and then that's about as far as I go. Now, yeah, there's this is another one too that it shows up. All right, but if I had this very long linear equation with many terms, right? If I had ut plus ut minus 1 plus ut minus 2, right? And if I'm to plot that out, it would look like that, something like that, right? And I want to convolve that with e to the minus t ut, okay, right? And you say, well, that's a really hard thing to do, right? But all you really need is to convolve ut here, right? You get one function, and then you use it here, and then you just substitute t for t minus 1. Substitute t to minus 1 into t, and you get the second part. T minus 2 into t, and get the second part. And so, but that's, I'm going to stop on that topic for more questions. Okay. And actually, there's no class Monday. It's a holiday. I should probably send out a reminder. But did that answer all your guys' questions? At least on that part.
It didn't answer the questions, but it definitely did help a bit.
It didn't answer?
No, I mean, like, I understand how you got it, but I don't think. Oh, I think I still need more time with it. Like, I understand how you got it though.
All right. Is there something more you want to see on that topic?
I think I should ask later once I get a better grasp of it.
Wait, you were breaking up a bit. I'm sorry.
I think I should ask again later once I get a better grasp of it.
Okay.
Like, I don't think it's the right time just yet. Yeah.
I mean, there's just a lot going on there. And yeah, I was going to have to delay that lab report because we hadn't hit convolution yet. I mean, it hadn't even started. I mean, we were still having, I think, we could still be having you know, we might still have questions on a sub-skill to that. Okay, oh, let me check the chat. All right, can we have some more review on rectangle? So I kind of need a little more detail about what you mean by the rectangle. I mean, yeah. I can put down, UT minus UT minus some delay, right? And that's 0, and that would be A. But I think you mean something more than that. Wei Hong, did you ask the review of rectangle? Was that you? Okay. Okay. If that was it, that's great. What else do you guys want to see? So So what I was trying to say, I mean, I actually did write out, detailed notes. All right. So there's just, again, there's these plots, which when I'm going over convolution, these are now kind of review topics, right? Where, what are these functions? Here's integrating something with time, integrating a delayed delta function just gives you that function at that particular moment in time. Impulse response, right? The relationship between impulse step and ramp, right? But then here is the convolution, right? And I kind of go through, so everything I wrote, I kind of I have it again, like with more details, but again, just simple stamps, steps and ramps and things like that, right? And again, I'm just doing simple convolutions. All right. But and yeah, step convolved with delta function minus an exponential. That in fact is that, you know, I called it something different. But in fact, that's the derivation I did, but you know, neater and maybe less steps. All right. So what I was trying to say is there's certain convolutions, right? Delta with anything, step to step, ramp to step, ramp to ramp, and step to this. Now, sometimes people will leave off the UT here because when you convolve it, you're going to get that. Okay. So what I'm trying to say is these are the basic ones. The answers are like kind of already there. But to go to the rectangle example, well, let me just zoom in some more. All right. And this is just, I'm giving you a broad overview here, is that I'm convolving a step with a rectangle, right? So then I expand it. UT convolve with UT. You already know that, or you will, that that's a ramp. Then I have minus UT convolve with UT that is delayed. Well, essentially, these are just steps convolved with steps, and one is just scaled by -1 and delayed by 1, right? I can find this common function, right? Because it's step times step. Sure, that's scaled. Sure, that's delayed, but it's still a step by a step RT. Then I just plug it back in, is that Z of t is my original UT convolved with UT, and then minus ZT, because it was minus sign, delayed by 1, just gives me RT minus RT delayed by 1. And then with a rectangle, you just, yeah, it's just like algebra, right? UT convolved with UT. UT convolved with minus UT delayed by 2. Minus this, convolved with that. Minus times a minus. And you just kind of work out the algebra and you realize no matter what, it's either, it's a convolution of a step with a step, and it's either multiplied by some number that's negative or positive, and it's delayed by some number. And so you can just kind of, even this step you almost don't need, but so the only convolution I found was the first one. And then I have minus this, minus plus, and then you get the thing, okay? And then, yeah, so I have a lot of worked out examples and things like that. But that's, in a way, yeah, we have this very convoluted convolution integral, okay? But really, you almost already know the answers, right? And then you just have to scale it and delay it, right? And if I came back down here, I shouldn't have scrolled too quickly. But notice, I'm convolving a UT with all these other things, right? Well, remember the first one of the first homeworks, right? Or, you know, hey, what is this function, right? And I'm just going to make that 0, make that 1. Oh, that function is RT. Oh, the slope flattens out, minus RT minus 1, assuming that that happens at 1. Then the slope goes down by 1, minus RT. I mean, that's 1, 2, I'll call that 3. T minus 3, right? Then the slope flattens out at 4, plus RT minus 4. Then at 5, it's going up. RT minus, oops, RT minus 5, right? And then at 6, trying to make it better, it jumps, right? So plus UT minus 6, but then it also flattens out minus RT minus 6. So now I've got this whole thing. And what if I wanted to convolve that with e to the minus t ut? Well, I just have to find RT convolve with u minus t ut, right? Because I have this function convolved with this convolved with this. And so really, once I find that answer, right, I just have to subtract it and delay it, subtract it and delay it, subtract, delay, subtract, delay. But this one, it's ut convolved with e to the minus t ut, which we've already done, right? But you just have to scale it by minus 6. So trying to integrate all this in one, do a convolution of that all in one shot is pretty hard. But if you break it down into its linear parts, right, you ended up finding only 2 convolutions, which more than likely you can just look up. And when we do the Laplace transform, in fact, that's what you will do. All right. Now, just something I want to say is that the book does an example of this shape convolved with this shape. And oh my God, is it the most, again, convoluted example I've ever seen. All right. And so they're just introducing the topic of convolution, but this is actually not easy to do. And the book goes through all these ticks and trips. I'm sorry. You have these limits, right? But you've got these delayed things and going on. And so they're showing you all these tricks with that when really, okay, there's RT, and it's not exactly the same, minus 2 RT, oops, minus 1 plus RT minus 2. Now they have a slightly different thing, convolved with e to the minus t. They go through all this business, and really it's one simple thing, RT convolved with, and actually it's not simple, it's hard. It's one convolution, right? So that whatever answer is, that goes right here in the first part, RT convolved with this. The next one, it's just whatever that answer is times minus 2 delayed by 1. Then whatever that answer is, it's just delayed by 2. And so you'll notice the picture when it comes, just kind of skip over it. And so what I did is I kind of reversed they show you the easy trick at the end when really it should be done at the beginning, because you just don't want to get involved in those. And I'm just going to call them ticks and trips and things to remember and memorize that I can't really keep straight myself. All right. But even, I haven't taught this, right, since January. But it comes back right away because I know to just break it up and do the simple things. Okay, I'm gonna read your chat. Yeah, convoluted convolutions, exactly, Joshua. Yeah. And I'm really grateful for the author. They made the book available for free. There's things that I think need to be adjusted, especially when it comes to op amps. But it's a good baseline, except I'll tell you, when I first taught this course, I started with that example and lost the whole class. I mean, like immediately. And it took me years to figure out a better way to give it. And then, and people still get lost, but hopefully not as many. Okay. But that kind of skill will be used on the exam, I think, question 2, but not this. Okay. Nothing that difficult. And so in some ways we've already done today, right? This kind of thing. And what I haven't shown you yet is you have to be able to plot it. But this kind of question and plotting it is question number 2. And the one where I just something like this, what is it? Right? That's question number 1. Here's a function, tell me what it is. Okay. And show me that logic, right? Oh, that the slope changes here, the slope goes to 0, the slope does this, slope flattens, level rises. And in this case, yeah, the level just rose. The slope was 0, slope is 0, level changed. So in that example, it's just a step. So that's question 1 of the exam. And yeah, I'll leave it at that. Okay, anything else? Well, let's see. Well, the air quality is 109, but maybe get out there and just get out of your room and do a walk or some exercise before you head back into work. But that's all I guess that's all I have, unless you guys have and it just can be anything. It can be from EE98. I don't have a set time that I got to cover certain things, right? This is all about you. Okay. Well, have a good weekend, all right?
Thank you, Professor. That was a good review of convolution. I needed it.
Well, we could all use it, I think.
Yeah.
It is, convolution is one of those things, when any EE sees that symbol, they kind of go, ugh. Okay.
Yeah.
But, oh, you know what? I know I said I was gonna go, but I just forgot. something cool. Hopefully I can find it. I mean, if you gotta go, you gotta go. Don't, don't. Oh, it's taking forever today. Ooh. Convolution of a step and with a triangle. Rectangle. So these links to this should be there, right? Oh, hey, that's me. Like, who's talking? So what we see, right, is this is the step function, and I'm just stepping it forward because time is like a parameter, and I just kind of keep stepping it. And notice this times 0 is nothing, right? And now all of a sudden I'm starting to get, so in here, right, I have a constant times a linear, so I'm going to get some kind of t squared, right? You can kind of see a squared function. And then it flattens out, but then notice, right, the area is limited. And so see how the overlap now is here? So that overlap is going to be the same no matter what. So it just keeps staying flat. Okay. And yeah, you could think of it is, what if this, instead of from 0 to 2, was 0 to a milli and it went up 1,000? It'd be looking like a delta function. And notice, even though there's this curvy part, if I zoomed way out, it would kind of be like a step convolved with a delta gives me a step. Okay, and there was another one. Well, anyway, the links are all there. Okay, all right, now I'm really gonna go. Okay. Take care, everybody.